Okay, so this question asks us to consider what happens when sodium reacts with oxygen, using the equation below. If we have how much sodium oxide, which is this chemical, will be produced when we have 51 grams of sodium reacting with an excess of oxygen. So to do this question, I'm going to write down here that we have 51 grams of the sodium, so I'm interested in this. I need to consider this. And the other thing I need to find out is the mass of this that will be produced. So I'm also interested in this. So I'm going to ignore the oxygen. The oxygen is in excess. That means it will help the sodium to react. But I'm only interested in the two chemicals I've drawn my circles around. And what I'm going to do, I'm going to start with this one because I know the mass of this chemical. So this is where I need to begin. So my first step is I need to convert the mass into moles. I like to work in moles in chemistry. To do that, I'm going to use this triangle, which is, remember, Mr. Moles lives underneath the mass. So my first job is to get the moles of sodium. And according to this triangle, if I want to find the moles, it's going to be mass divided by mR. So let's write that down to remind myself. So it's a mass divided by mR. So the mass from the question is 51 grams. The mR, remember, this is the relative atomic mass, in which the sodium is 23. So I get 51 divided by 23, put that into your calculator, and I'm going to get an answer of 2.22 moles of sodium. My next step is to look at the ratio, the stoichiometry, between the two chemicals I'm interested in. So I have 4 lots of sodium forming 2 lots of sodium oxide. We've just worked out that we have 2.22 moles of sodium. So let's put that underneath here. We have 2.22 moles of sodium. And I need to find out how many moles I'm going to get of the sodium oxide. So that's what I'm trying to do. So if I go from here to here in that same direction, I go from 4 to 2. How do I do that? I divide by 2. So to keep that ratio the same, I divide this by 2, and that's going to give me 1.11 moles of sodium oxide. Okay? Now I've got that many moles of sodium oxide, I can do my final step, and my final step is to convert that moles into a mass of sodium oxide. So again, I go back to my triangle. The mass is the mR times moles, so let's write that down. mR times moles, okay? Now we're doing the compound, so the mR might take us just a second to find, so let's just move this up, give me a bit of space. So the mR of sodium oxide, in here I've got 2 lots of sodium, I've got 1 lot of oxygen. Sodium is a mass 23, relative to a mass of 23, oxygen's mass is 16, so that's going to be 46 and 16. Add those together, and that gives an answer of 62. So I'm going to put this out of the way for a minute. So the mR for sodium oxide is 62, times by the number of moles, which we just worked out, is 1.11. When you work that out together, we get an answer of 68.82 grams as a final answer.